So the idea here is we do not have right triangles. These are in non-right triangles. Technically, these still work in right triangles, but we've expanded our universe now. We'll have some triangle, A, B, C. Across from side A is little a, across from side B is little b. We do not have Pythagorean. C is no longer a right angle. We don't have a right angle. No Pythagorean. We still have A plus B plus C, the measures of those angles, equals 180 degrees, because it's still a triangle, but we don't have a right angle. We don't have the Pythagorean theorem. A squared plus B squared does not equal C squared. In fact, that's what law of cosines is, which we'll do next time. It's the correction to Pythagorean. Okay, what we have here instead, our first set of formulas is the law of sines that says for angle A, sine of angle A divided by A is sine of angle B divided by B, which is sine of C over C. Now, this is not, you don't have to use all of these. This is saying you can take any pairs here and set them equal. Or remember, with fractions, we can always flip over both sides. I could, if I wanted to, write these like this. Now, you got to be careful here. It's very important to make sure your lowercase and your uppercase look different. Uppercase are the angles. You can't take sine of a side. Lowercase are the sides, the lengths of the sides. And everything we do here will have our calculator in degree mode. Okay, we use law of sines in these three scenarios. Angle, side angle. Angle, most places write this side, side angle. I tend to write angle, side, side. And angle, angle, side. This is what's called the ambiguous case, where you might sometimes get two, ambiguous. You might sometimes get two different triangles that meet the conditions. Sometimes you get one triangle, sometimes you get none. These two will always have a unique solution. These two are actually equivalent. Okay, so we're going to start with one of those. We'll do an angle, side angle. So let's say we're given oh, 25 degrees, 62 degrees, and 15 feet. So let's see what we know. If I go around, say in a circle, I know an angle. The next thing I have written down is a side, and then I know an angle. I know two angles and the side in between those angles. This is an angle, side angle scenario. I know two angles and I know the side in between them. If I had this, I'm going to change it back, but if I had that, that would be angle, then side. Okay, when we're solving a triangle, our goal is to write this table. If you don't write this table, you've gotten the question wrong. We want to find everything. They're always going to tell us 3 and we have to find the other 3. We do not have Pythagorean. So side B is 15 feet. Don't forget our units here. A is 25 degrees. Don't forget your degree symbols. C is 62 degrees. Okay, finding the third angle. If you know two angles, you know the third. The third angle is 180 minus 25 minus 62. So I got my calculator here. I'll type that in. Minus 25 minus 62. 93 degrees. So anything you find yourself, you should circle. Just as a reminder to yourself, this is not something I was given, it's something I found myself. Okay, now I need to find A and C. So I need to write down my law of sines formulas. I want an A or a C in there. So I could write this, say sine of A over A equals sine of capital C over little c. And I like to play this little game. Figure out what I know and what I don't know. Do I know angle A? Yes. Do I know side A? Nope. It's not filled in yet. Angle C? Yeah, I know that. Side C? Oh, no, I don't know that. There are two things in here I don't know. This won't help me. It's true, but it won't help me. I need an equation that has only one unknown in it. I know all the B's, so I need to get B involved here. Maybe sine of A over little a equals sine of capital B over little b. I know. There's only one thing I don't know. I can solve that. Now, it's perfectly okay to just flip both of these over. I like to just think cross multiply. So B times sine of A will equal A times sine of B. I just cross multiplied. I'm trying to get A by itself. So A will be B sine of A over sine of B. Okay, so that would be, let's write everything in. Make sure the key here is to keep your angles and your sides straight in your mind. Little b was 15. Angle B was 93. Okay, so now I just want to type that in the calculator. I'll share that screen. We want to make sure we are in degree mode. Okay, so I'm going to go into mode. I'm in degree mode right there. So what did I have? 15 sine of 25. I need to close that parenthesis. Divided by sine of 93. 6.35. We're going to round these to 2 decimal places. Units here, all my links are in feet, so this will be in feet. I'm going to immediately put that in my table before I forget. 6.35 feet. I found that, so let's circle it. Now your gut says to find C, Pythagorean, right? We don't have Pythagorean. No, we got to use law of sines. So I would do sine of C over C, sine of B over B. So C will be B. Sine capital C over sine capital B. Now on my calculator, most of that's already in there. That looks a lot like what we wrote right here, only now, instead of having a 25 here, I'm going to have a 62. So this is 15 sine 62 degrees over sine 3 degrees. So I'm lazy. I don't feel like typing all that out again. I'm going to go back up into this expression. I'm just going to hit second entry right there and change that 25 to a 90, or what was it? A 62. Hit enter. And now I've got C, 13.26. Feet. So let's put that in our table. Don't forget the feet, they're thrown. Now, here's a quick check. The biggest side will always match up with the biggest angle. The biggest side is 15. The biggest angle was 93. The smallest side will always go with the smallest angle. Smallest side was 6. Smallest angle was 25. So that's not a guarantee that it's right, but it's a good check. That will catch most of your mistakes. Okay, that was an angle side angle example. Now let's do one of the hard ones. Let's do an ambiguous case, a side side angle. Okay, so I want ABC. We're going to call this guy 25 degrees. This side will be 10. Let's go with meters. And this side will be 15 meters. Okay, so this is if I go around, I know side, then the next thing I know is a side, then the next thing I run into is an angle. That's side, side, angle. Or another way to think of it, I know two sides, but the angle I know is not the one in between them. I don't know this. That would be side, angle, side. I know one of the other angles, side, side, angle. These are a pain. These are the hard ones. We write out our table. Let's fill in what we know. B is 25 degrees. Little b is 15 meters. Don't forget your meters. Little c is 10 meters. Okay, and we're going to use law of sines. Notice I don't know anything about a. So if I write sine of a over a, that's two unknowns immediately. That's no good to me. So I have to use these four. So I have to do sine of b over b is sine of c over c. I know that, I know that, I know that. The only thing I don't know is capital C, the angle. So sine of capital C, I'm going to cross multiply or multiply this C up. So that would be 10 sine of 25 degrees. Don't forget your degree symbols. Over little b 15. So I'm going to type that in the calculator. I want you to see this. Sine of C is this, 10 times 25 over 15. Ten sine of 25. Don't forget your parentheses, divided by sine of 15. Oh, no, I typed it wrong. 10 sine of 25 divided by 15. It was not a sign on the bottom. 0.2817. We always want to go 4 places on these. 0.2817. So this says sine equals that. Remember from last week, sine equals that an infinite number of times. There's not just one angle that gives me this. There are an infinite number of angles, and in fact, there are 2 different places where this will happen between 0 and 180. My calculator, when I do this next step, will always spit out an angle in quadrant 1. Remember, inverse sine always spits out angles between negative 90 and 90. We can't have negative angles in a triangle. So my calculator is only going to give me one possible answer here. It might not be the right answer, or there might be 2 possible answers. So this is one possibility. The other is that thing, or 180 minus that thing. The calculator will only give you one answer. Think of like a unit circle. The calculator will give me this answer. This is the other possibility where we have that same reference angle, 180 minus that angle. So let's type that in the calculator and see what we get. Inverse sine of that answer. And I could type it just like that. I can say inverse sine, second sine, of my answer, hit enter, 16.36 degrees. So that's one possibility, is 16 degrees. Okay, there's another possibility. Or C equals 180 minus that, 16.36. So that would be 180 minus that answer. Clear 180 minus that last answer, 163.64 degrees. So that's the other possibility. Now, a lot of times you'll get here and that second one you found, it just doesn't fit inside a triangle. There's not room for it. That's when you get lucky. Sometimes both of these work, they're okay, and then you have to redraw this table and start over. You have to solve an entire problem with this answer, start completely over, solve an entire problem with this answer. But in this case, I've already got 25 degrees in my triangle. I already got one angle that's 25. If I add in another 163, I'm already over 180. There's no room for a third angle. There's no room for these two. These two will not fit in a triangle. Sometimes you get lucky, and in this ambiguous case, that second one just doesn't fit. It's already 25 plus 163 is already bigger than 180. So we only get one possible triangle. So let's put that in our table, 16.36 degrees. If you forget the degree symbol in these, I'm going to take a point off. That's a unit. All right, now we got to find our A's. So I would do, first off, these three still have to add up to 180. So A is 25, or 180 minus 25 minus 16.36. Won't show it, but I'll do that. 180 minus 25 minus 138.64. I could put that in my table. As soon as you find something, put it in your table or you're going to forget it. And circle it if you found it yourself. Now we got to find side A. We cannot use Pythagorean because this is not a right triangle. But we could do, I'll write it the other way. A divided by sine of A equals, B has prettier numbers, so I'm going to use him. I could have used C. Keep in mind though that this was an approximation. So if we use that error, that approximation error will compound and our next answer will be even more of an error. So it's better to go back to the exact numbers anyways. So little a, multiply that sine A over. Will be 15 sine of 25 degrees divided by, no, sine of A, 138.4 degrees divided by sine of 25. degrees. So we'll type that in the calculator. I'll share it. 15 sine of 138.4. Don't forget your parentheses or it will mess things up. Divided by sine of 25, close the parentheses, 2356. And that was in meters. So we put that in our table. And then as a quick check, biggest side and biggest angle should match up. They do. Smallest side and smallest angle should match up. And of course, the middle side and the middle angle